Alright, hey guys. So I'm recording in a different way than I normally would have if I were at school, so bear with me a little bit here. But I did change notes around because I think it's going to make our lives a whole lot easier. So either you were able to print this page or you're just going to copy it down on your own piece of paper. That's completely fine. Just find some blank paper anywhere within the packet. So we are starting our statistics unit today. So with statistics, personally one of my favorite ones. I'm a little sad that you don't get to be in school for this one. So statistics basically is you're just studying data. So you're just looking over data over and over again, analyzing it, trying to come up with your conclusions. Based on your numbers, some people can come up with different conclusions, and that doesn't mean that they're wrong. It's just you are seeing different patterns within the numbers, and you can still be completely right. As long as you can explain it and the numbers make sense, you can be very right about it. So we are starting off with pretty much just a little bit of review of stuff from Algebra 1 that you did. So taking a look at our first example here, we have some biologists are studying the weight of brown trout in upstate New York streams. They capture and weigh 15 brown trout from the Sawkill Creek in Red Hook, New York. Their weights, accurate to the nearest hundredth of a pound, are given below. So here's the weights of those 15 trout. Now, since they only collected 15 trout, that means we are looking at just a sample. There is no way there are only 15 trout in that creek. There's definitely going to be a lot more. So they only took a sample of them because they can't possibly catch all of the brown trout that exist there. And now because we are also looking at just one piece of information, we are looking at their weights. This is what we call univariate data because it's just one. You've also spent some time looking at some bivariate data, which would be 2. Anyway, so we've got all these weights here. So use your calculator to find the mean weight, symbolized by this little guy here, x bar, and the median weight. Round your answers to the nearest hundredth. As you can see, I already have my answer here, but we're going to go through the steps again of how to do this in your calculator. So once you turn your calculator on, I'm going to zoom out a little bit here so I don't cover my numbers and you can still see what I'm doing. So if you push your stat button, you want that first one, you hit enter, and then that gives you your lists, which are a little tricky for you to see. There you go. Now if you have numbers in your list already, like I currently do, if you go to the top of it so that L1 is highlighted, hit clear, down arrow, and it clears out any numbers that you may already have in there. You may have stuff left in there from previous years. So then go ahead, begin typing in the numbers that are the weights of the brown trouts that they caught. 0.23, 2.39. After each one, you are hitting enter if you don't remember. 1.79, 1.48, 1.17, 1.41. Okay, so I got my 15 numbers in there. If you look at the bottom down here, it says L1, and then in parentheses it says 16, so that tells me it's waiting for my 16th number, which I don't have one because we only had 15 trout. So that's how we know we got it done correctly. Also, if you go back up to that last one, it's got that 15 in there, so that's telling you that's your 15th number. So we got all 15 numbers in there correctly. So again, we're trying to find the mean and the median. Excuse me. So if we go back to stat, we're going to go over to calc this time, and you want that 1 var stats. Most of yours would come up with this little list here. So that first one should say L1 frequency list should be blank. We'll go down to calculate, and we'll hit enter. And this is all of our information. I don't know if you remember this from a couple years ago. So that first one, that is our mean. So as you can see, I already copied it down right here. Our mean was 1.92. Our median, which if you recall, is also your Q2. Your median is your middle number. So if you just arrow down in your calculator, I apologize, it's not showing up too well on here, but our median is 1.62. So there's our 2 numbers there. They want us to use our calculator to find the first and third quartile values. Those, again, show up right around your median. You got your Q1 and your Q3, so those two numbers are right from that table. Again, if you want to write it down, that was our 1var stats, is giving us all of this information here. C, they want us to calculate the range, so that's your max value minus your min value. That's how we get our range. And then our interquartile range is your Q3 minus your Q1. The interquartile range is used to find the middle 50% of your data, because Q3 represents your 75th percentile, Q1 represents your 25th percentile, so subtract them, you got your middle 50. This number is very useful a lot of times when we are analyzing numbers. So there's our basic, where we find all that stuff. So continuing on, mean and median are what we refer to as measures of central tendency. They help us figure out the center of our data. And there's a lot of reasons why we want to know the center of our data to be able to figure out and analyze certain problems and answer certain questions. However, the quartiles, the range, the interquartile range are all measures of dispersion. How far apart is that data from each other? How widespread is it? Is it really narrow together? Is it further apart? That's what those numbers help us to figure out. So let's take another look at this using a frequency table. So we're going to switch it up a little bit. We got a frequency table down here. So we've got that marketers are studying the ages of teenagers using social networking sites. They survey 100 teens for a particular site and find an age distribution given in the table below. So here's our table here. So what we're going to do, we're going to type our new numbers into our lists. So again, I go to Stat, Edit, clear out my list 1, and my ages are going to go into my list 1. So 13, 14, 15, 16, 17, 18, and 19. My frequencies are going into my L2. So this time we have two lists of numbers. So again, age is your L1, frequency is your L2. L1, L2. So we're still going to do 1var stats because we're really still looking at one variable here. We're looking at the age of the teenagers. We're not really looking at frequency. That just tells us how many 13-year-olds there were. There's 5 13-year-olds. There's 11 14-year-olds. There's 17 15-year-olds. So this is just telling us how many of them there are. So instead of sitting here and typing 13 in there 5 times, we can use the little frequency here, and it makes it a little bit easier for us to type in the table of values. So again, we still have one variable that we're looking at. So we're still going to do 1var stats. Only this time under frequency list, you're going to hit second and the number 2 to bring that L2 in there. You had a frequency list. So we need to get that frequency list listed in the calculator. So L1, L2, and then we go to our calculate, and it gives us all of our numbers here. So the mean, that is our first one, so that was our 16.11. They wanted 75% of all the data fall at or below what age? So that 75%, that's your Q3. And then what is the modal age for this data set? The one that has the highest frequency would be 16. So that's how I can find that from my frequency table. Okay. Let's take a look at these next ones. So number 3 we're looking at here, we got 32 adults paid $12 to attend a concert, while 68 children had to only pay $8 to attend the same concert. They wanted to know what is the mean ticket price paid. So again, mean is the average of all of your numbers. So to kind of make it go a little bit faster, we'll multiply 32 times 12, because 32 adults all pay $12. And then 68 times 8, add them together. So 32 times 2, 8 times 68, gives me a total of 928. And then if you add these numbers up to find out how many people were there total, that's where we get 100. So 928 divided by 100 gives me 928 is our average ticket price there. So next one, which of the following formulas written in summation notation? So summation notation. I don't know if you remember this, but we did talk about that back with our sequences. Is that little funky E guy. Remember when you get that little E guy, that means you are adding all of the terms together. That's what our summation does, is it adds everything together. So we want to know what summation notation would represent the mean of this data set of x1, x2, all the way up to xn. So again, keeping in mind, mean means you're averaging them all together, and then you would divide by how many is there. So since this is x sub n, we don't actually know how many are here, so that's why I'm dividing by n. Whatever that last term is, that's what we want to end up dividing by, because that's how many terms we have. So if we look at our choices, this one is just adding them all up. That's only half of our equation. We need to add them up and then divide by how many is there. This one's not dividing by how many is there. This one is multiplying by how many is there. 2 was almost there, except it had that little squared notation to it. So this one ended up being choice 4. So it's saying adding up all the terms. That's what our little summation guy means. And then the 1 over n means it's dividing by how many terms we have. Okay, for our next one, we have the mean and median of the following ascending data are the same. Find the value of k. So if we look here, we got 2, 4, 6, 7, 8, 9, 11 k. We're trying to figure out what k actually equals. So what they told us is your mean and your median are the same number. They have to be equal to each other. So what I did here is I was figuring out what my median was. Now, it's in between 7 and 8. So that means my median is 7.5. So that means that my mean is also going to be 7.5. So mean is 7.5, median is 7.5. So I would calculate my average, my mean, by adding them all together and dividing by how many is there. So adding up all of my terms, dividing by 8, because I have 8 terms there, is going to equal 7.5. So then to solve it, all of these numbers added together is 47, multiply by 8 to get it out of the fraction. That's where my 60 comes from. Subtract it over and we get 13. So next one, Nalia wants to average 30 minutes per workout for 5 days this week. So for the first 4 days, she works out 25, 38, 40, and 29 minutes. How many minutes must she work on the 5th day to reach her mean of 30 minutes? So we know 4 of them. We don't know the 5th one. So we can call the 5th one X. And it's kind of like what we did on the last one. Add up the ones you know plus the one you don't. Divide it by 5, because it would end up being 5, equals our mean here of 30. Multiply by 5, add what you know, and then subtract. Her 5th workout would need to be at least 18 minutes in order for her to reach her goal. And then our last one here, looking at test scores, here's the scores he has. There's only 2 tests, but they want to know what is the minimum score he can get on the 4th test and still have a mathematical chance of reaching a passing average of 65. So I set it up, adding up the ones I know, plus the 4th one needs to give me a 65 here. So then I solve for X, and we get a score of 87 or higher would give him an average of 65.